Hello, I'm Dr. Gajendra Purohit and you are watching YouTube channel where I upload videos for engineering mathematics BSc students. I have started uploading videos on graph theory and we've started discussing many basic concepts and terminology in graph theory. And I think you will like it very much. You can go to iTab and watch my videos. You can find the links in description below and also in the comment section. So today I am going to discuss with you all some important graphs like what is complete graph, regular graph, bipartite graph, what is complete bipartite graph, and many more graphs which I am going to discuss with you. So listen carefully. Let's start with some important graphs. First is our complete graph. A simple connected graph is said to be a complete if each vertex is connected to every other vertex. If each vertex is connected to all other vertex, then we will call such a graph as a complete graph. Like this vertex is connected to this. There are three vertex. This vertex is connecting to this one. This is connecting to this one and this is connecting to this. So each vertex is connected to the other vertex. So this is a complete graph. You can understand it in this way also, like this is connected to these four. It's connected to all four, right? So what we have is a complete graph. We will talk about what is a regular graph. A graph G is said to be a regular if every vertex has the same degree. I told the concept of degree. You can watch previous video on iTab where I told about the degree. Degree means how many edges are coming out from a vertex. That is the degree, right? So if we have any graph where each vertex has an equal degree, we have a regular graph. It has 2 degree, it's 2 degree, it's 2 degree, and it also has 2 degree. So it's a regular graph. This is 2 regular graph because every degree is of 2. Here, each one of the degree is 4. 1 is coming, 2 is coming, 3 is coming, 4 is coming. All 4 are connected to the vertex and 4 edges are coming. So what we will get next? 4 regular graphs, right? If by chance any graph is that each vertex has 3 edges, it will have 3 degree and we will get 3 regular graphs. Is it clear? This needs attention. Let's move ahead. So now let's talk about what is bigraph or bipartite graph. If the vertex set V of a graph G can be partitioned into 2 non-empty disjoint subsets X and Y in such a way that edge of G has one end in X and one end in Y. Okay. So listen students, let's say we have an edge to connect with the vertex. One end of it goes into one set and the other end goes into the other set. Look, first of all, we have this set. Write down all the vertex we have in one set. Now we have these connected together. In this you see this is connected, this is connected. So this one will go in one set and the rest of these, meaning this one and this one, will go in the other set. Look here. Let's say if I see this, I take this one as X and the other one as Y. In this I have taken V1 here on the right. What will go in the second set? One will go to V7 and one will go to V2. Is it clear? Now let's talk about V6. So listen, this V6 is connected to this is connected to this, right? So this vertex, right? What will this go into? This will go into this one because these two are connected to each other. So what will come to as this end? V6 will come. This is the type we will be talking about. So this one is connecting to this one as well. So this one is, which one will it go in? It will go in this one, right? Because we have this in it, this V5 will come. Clear? Now see, it is connecting to this. So this means that this one is connected to this one. And if this one goes away, then what will go to us? V3 will go away, right? So if you see this, it is connecting to this one. So we also have this because it is not connecting to each other. Is it clear? So whichever vertex is connecting to any edge, students, so one of its endpoint will go to one set and the other one will go to the other set. And both are disjointed from each other, right? This is I am explaining and here is V5. This will come to us and we will get V4. And what will happen for these two? We will have separate partitions. And it needs to be noted that whatever edge we have, one of its points is going into one set and the other point is going into another set. What do we call this type of graph? It is called bipartite graph. We'll talk about connected graphs. What is connected graph? If by chance an undirected graph is said to be connected if there is a path between every two vertices. What should happen between each of the two vertices? A path should be there. Like A is also having a path with B. In this, path is happening with C and with D, right? So what is happening that from each of the vertices, a path is happening. This type of graph is called a connected graph. But one thing to be noted is that a connected graph is not bipartite. Now, why is it not bipartite? Because here I want to tell you that, let's say we have this. We have a vertex. Its edge is this and its edge is also this. So we take one in one and the rest, which is the other end, is taken in the other. Getting my point? For example, if I say that A will come here, what will come? B will come, C will come and D will come, right? Now what happens as soon as A came, BCD came here? Suppose we have two things here, we did both separately, right? We have a vertex which is A. The end point of its edge is coming to us. B is also coming, C is also coming, and D is also coming. But now let's talk about B. If I take B here, B will come here. Okay, now from B, which edge is connecting to us? One is A, one is C, and the other is D. Right, students? This will come, but this is going to be bad because C is also coming with B and here C is not coming with B. We cannot do this here. If any graph we have is connected, it is not bipartite. The definition of bipartite, which I told you, will make sense to you, and by this perspective, we can see it. So let's move ahead. Now we have a complete bipartite graph. What is a complete bipartite graph? The X and Y sets which we took. If in two sets we had vertices, if that is connecting with the other set, with each and every vertex as an edge, then with us what do we have here? We have a complete bipartite graph, right? Now let's take an example. Suppose we have a graph here. Now with us, which two sets can we take here, students? When we take this and this, both are vertices, they are not connecting with any edge. So V1 and V4 will move apart. V2 and V3 will move apart, right? But this V1, it is connecting with this and it is also connecting with this. V4 is connecting with this and is also connecting with this as well. So a graph of this type is complete bipartite graph and it is called K22 because there is 2 in this and 2 in this also. So we have this K22 denoted. The number of elements we have in this set, they will come first. All the elements we have in this set will come later. About the graph that I told you, if I want to tell in this graph, see this graph. If we want to see this here, then this is X and this is Y. Then what should happen with each vertex of this? It should be connected, like V1. Now we see if V1 is connected with V7. Yes, it is connected. Is V1 connected to V2? Yes. But is V1 connected to V5? No. There is no edge between V1 and V5. So this is not a complete bipartite graph. So this needs attention. Through this method, you can check V6. This is V6. V6 is connected with V7. Yes, connected. V6 is connected to V2. Yes, it is. With V2, V5. This is happening. Every vertex must be, but V1 did not connect. V6 did connect, but V3 will not be connected. If our every vertex is being connected to every other vertex of this, then it will happen. If one is happening and rest is not, then it will not be a complete bipartite graph. This needs attention. Now we will talk about subgraph. What is subgraph? It's very simple. This is the graph we have. If we remove some of its edges here and then write the graph, then we will be getting a subgraph. Ultimately, what is happening? Meaning of subgraph is subset. It's getting a subset, meaning vertex and edges. What are we doing here? The vertex is the same and the edges are less. So this will be what here? Subgraph. So here, students, let G, V, E be the graph and V dash be the subset of V and E dash be the subset of E, whose end point belongs to V dash. Then G, V dash and E dash is a graph and it is called a subgraph of G, V, E. Then we will have a subgraph of this. We will talk about decomposition of graph. What is the meaning of decomposition graph? This is a graph. So students, if I break this graph and then break it into two parts, and now if I do union, then this graph will appear, right? And if we take the intersection, then what should we get? We should get a null graph. If this happens, then what we get is called decomposition of graph. For example, like this graph, I have broken it into two different parts here. If I take its union, after taking, the graph will come back. And if I take the intersection of this, what we will have here at the intersection is these two vertices are coming in common. What will this come? V4 will come. And what will this come? V5 will come here. When the edge is not coming here and whenever we have a vertex here and the edge is not coming, then it is called null graph. By union of these two, the complete graph G is formed. By union of these two, the complete graph is G. On intersection, we have a null graph. This is the type of graph which is called decomposition of graph. This is a type of direct product only. Here the union is completely set. And what is the intersection there? It is empty. In this we will talk about complement of graph. What is complement of graph? For this graph, if we want to find its complement, the vertex which we have and the edges with which they are connected, just remove them, and which are not connected, add edges there. Okay. For example, these two vertices are not connected. It will go here. So it will go here, 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 and here. Now see here, these two vertices are also not connected. This is connecting and this is not connecting. We will remove this one. We will remove this edge, this edge, this edge, and this edge. We will remove the black lines which are there. And wherever it is not being connected, this is not happening, this not happening, we will do it. Right, there is a need to understand this. The vertex which we have here, those which does not have an edge in between, we will add edge there. Where the edges are, we will remove them. Such graph is called the complement of a graph. This will be the complement. So this is important. You need to keep this in mind. Now let's see another example. Let's say we have this graph. We have 4 vertex here and its edges. If we want to find the complement of this graph are the 4 edges. These are not connecting together. These are not connecting. What will come of this? There will be a complement, and you need to understand this moving forward. Now what is a planar graph? For example, if there is any graph where the edges are cutting each other, then remove its edge. That means it should not cut, right? So if we take this edge and move it like this, then what will this become? It will be a planar graph. A graph which can be drawn in the plane so that its edges do not cross is called a planar graph, right? So this is called a planar graph. Okay, let's move ahead. We have a question, draw a planar representation of graph given, and you need to draw planar representation. First, let's write the edges. So now here we have the edges. This is A, B, C, D, E and F. Right, students? Now students, we need to draw its planar graph. Here we have the edge, so we will do it here like this. Clear? So what will happen? Whatever the edges are here with us, which are crossing each other, like this you are seeing. So these are not cutting among themselves. This is not doing and this is not doing. But this edge which is coming, here this one is going like this. So we will do it like this, right? What is this doing? It is cutting. So we will do it like this. By this method, we will do it. So this will be the planar graph of what will come to us. Its planar representation will be done. The edge we have, which is cutting, take it outside. So this is the planar representation, students. Let's move forward. Question is there. Draw K34 bipartite graph. What we have is a complete graph. The meaning of a complete graph is, here we take 2 sets which are sets of vertices. And whichever edge has an endpoint, that vertex goes here and the other vertex goes into the other set. And students, what happens with this vertex here and this vertex here? It connects with some edge. This type of graph we have here is a bipartite graph. In one set we have 3 vertices and in the other set we have 4 vertices. So it will be 3, 4, right? This needs attention. So suppose I take this one as V1, this one as V2 and this one as V3. And here students, see, I am taking these 4. V4, V5, V6 and V7. Because we have a complete graph. So in the complete graph it happens that we have this one set and this one set. And this is the end point of everything. It is not connecting to each other. There is a need to pay attention. This will connect with this. This will also happen with this. This will also happen with this. And this will also happen with this, because I have a complete graph. We will talk about it. This is connecting with this. It is connecting with this. It is connecting with this. And it is also connecting. Talking about this. This is happening with this, with this. This is happening with this too. And this is happening with this. So students, this graph will be a complete bipartite graph, and this will be K34, this 3 and 4. This is called as K34. So like this we draw this. Let's move forward. In this you are being asked which of the following is a regular graph. What is a regular graph? Any graph whose degree of every vertex is same. What we have is a regular graph. So here students, in this graph, this vertex has a degree 2, this has a degree 3, this has a degree 2 and this has a degree 3. So this will not be a regular graph. Here this degree is 2, this is 2, this is 2, this degree is 2, this degree is 2 and this is also 2. So it's a regular graph. This degree is also 2. All degrees are 2. Degree of every vertex is 2. So this is regular. It's 3 degrees here, as you can see. So this graph is also a regular graph. Let's move forward. So see, now the next question is being asked to you. Which of the following graph is a bipartite graph? I told you about the definition of bipartite graph. We have A, B, C. We have this vertex which is connected to the edges, P, Q, R, S, which is connected with this and this. As you see here, that this A, B and C is coming in one set separately. And P, Q, R and S are forming another set separately. So this is a bipartite graph. But see this here, students. Here F is coming with E, with D, with C, with B and also coming with A. Right, students? So every vertex is connected to some other vertex and edges. Meaning we have this graph connected with us, and whenever any graph is connected, it is not a bipartite graph. So we won't have this bipartite with us, but we will be having this ICE bipartite graph. Let's see about what does handshaking theorem says. So in the handshaking theorem it says any graph that we have, the degree of its vertex and its sum is equal to twice the number of its edges. Clear, students? Here we have the theorem that sum of degrees of vertices of a graph G is equal to twice the number of edges in G. Sum of the degrees of all the vertices of the graph is equal to twice the number of edges of the graph. So if we talk here, we can easily understand. I will explain it by an example. Try to understand it. If we have multiple vertices, then what do we find? We find the degree. As you can see, the degree of this vertex is 2, its degree is 2, its degree is 3, its degree is 2, its degree is 1. So 2 plus 2 is 4, plus 2 is 6, and 3 is 7. No, 2 plus 2 is 4, plus 2 is 6, plus 3 is 9, and plus 1 is 10. What is the sum of degree of this graph coming? 10 is coming. Now let's count the edges. So you see, students, 1, 2, 3, 4, and 5. So we have 5 edges coming, which is equal to twice of what it is. So if we double the edges, we will get equal the sum of its degrees. This way you can easily verify the theorem. Is it clear, students? Thank you so much for watching. In next video, I will discuss about matrix representation of graphs, how we represent graph using matrix. My playlist where I upload videos on discrete mathematics, you can go there to watch it. My new channel where I am uploading short trick, you can find its full playlist here. You can go here to subscribe to my channel and follow me on Instagram, students. Thank you for watching. Like, share and subscribe my channel. Thank you very much, everyone. Bye.